Hey everyone, this is lesson 2 of our geometry support. This time we're going to be focusing on applying the distributive property, which we'll talk about what that means in a second, to rewrite expressions. And this is our clusters. We want to be able to write expressions in equivalent forms to solve problems. And that's really what our MCAS focused on, so that's where we're headed today. All right, so first I want to think about distributive. I don't know if you've heard distribute or distributive before, but one way to think about it is like people often distribute like things to people. Like if I was passing out papers to a class, I would be distributing papers to the class. So it's me giving something to all the other members of a group. All right, so let's see how that applies in math. Down here we have the first expression right here. It has a 3 being multiplied by this entire group in parentheses. So the distributive property states if we're multiplying, we have to distribute that multiplication to each member of the group. So this 3 needs to be multiplied by each piece of the group after it. And the way I like to write that is with arrows. Again, this 3 needs to be multiplied by x, so I leave a little arrow there to help me out. 3 needs to be multiplied by this second member, which is a negative b. And then lastly, 3 needs to be multiplied by our positive 2. In general, that's what distribution is. So let's write it out and see if we can simplify this expression. 3 times x, that's just 3x. 3 times negative b is negative 3b. And 3 times positive 2 is 6. So I did the multiplications kind of fast, but the idea is the same, that we can just take a multiplication over a group and distribute it to each of the pieces. I also have to remember that I have a plus 3 there. And then I always want to look at my expression and see if I can rewrite it any simpler. I see I have x's, I have b's, and I have 2 constants. Both of those are constants. I can combine those. They're like terms. So I leave my 3x, my minus 3b, and then my 6 and my 3, those can both combine to make a positive 9. So there we've taken an expression that required us to multiply over a group, distributed, and then rewritten it in a simpler form. All right, next question. Here it's pretty similar, but we're distributing not just the 2, it's actually, though, a negative 2 out front that we need to distribute. So I'm going to take that negative 2, distribute it to both of our pieces. Well, 10n I'm going to leave right now. Negative 2 times n is negative 2n. Negative 2 times 2 is negative 4. So the arrows really help me keep track. Put them together. I get 10n minus 2n. That is, those are like terms. Yeah, both of these are n's. I can combine those. 10n minus 2n is 8n. And then the negative 4 is left over underneath. So that's 2 examples of how we can apply the distributive property. Down here, I see there is, again, a negative out front. There's no number to distribute. Here's my group. If I was imagining a number there, though, I'd like to have a number there so I could distribute it. I'm just going to make it a 1. Right? 1 is the same, 1 times it is the same as just having nothing there. So now I have a negative 1. Now that's the thing I can distribute to both of these pieces. And if I'm moving too quickly, go ahead and pause, take notes as you go, continue the video. I just don't want the recording to last too long. So negative 3a I keep. Negative 1 times 2b is negative 1 times 2 is 2. Right? Negative and a positive makes a negative 2b. And a negative and a negative, that gives me a positive 2a. And if I look at this again with my like terms, I have 2 terms with a's in it and 1 term with just b's in it. Well, I can combine my like terms. 2 take away, or negative 3 plus 2. Make a little number line here. If I'm at negative 3 and I want to add 2, I'm going to go up 1, up 2. That'll take me to negative 1. So rewriting, I can combine my a terms to be negative 1a minus 2b. And then again, just so we see it, that's the same as negative a. We can always write or not write the 1 in front of our expressions. Negative a minus 2b. Awesome. And there's one more example. Here, if our job is to distribute, we now have, instead of just one thing to distribute like we had before, we actually have two things. There's a y and a 2 that needs to be distributed into this group right over here. Well, if I'm going to do that, I'm just going to take each one, I'm going to take y, and I'm going to distribute it to both the y and the negative 4. And I'm going to take my 2 and distribute it to both the y and the negative 4. So if I do the red ones, y times y is y squared. Y times negative 4 is negative 4y. That takes care of my first one. Now I can make a note and be like, I'm done. I've distributed my y to both of the pieces in the other group. And if I do the ones I did in blue, 2 times y is plus 2y. And 2 times negative 4 is negative 8. Great. I'm going to look for like terms. I see I have a y squared, I have a negative 8, and I have 2 y terms. Well, the 2 y terms I can combine. Y squared stays, negative 4, positive 2. If I'm at negative 4, I move up to negative 3, negative 2. So it's negative 2y, and then negative 8. And again, if I move too quickly on these, I'm just trying to keep the video short. Go ahead and pause, go back, take notes as you go, or even pause before I start the problem so you can try it on your own. But that allowed us to rewrite. Alright, so really we're just taking this distributive property, applying it, and rewriting our expression simplified. 2 ways to practice this. The first one just asks you to use the distributive property and combine like terms to rewrite expression. And then on the back side, it has you match each of these expressions on the left with the one on the right. Here it doesn't specify, but you may need to combine terms, you may need to distribute, simplify them to be able to match up which ones are equivalent. Alright, see you next time.